Hello, I'm John Shavacco, the co-chair of the NY-GEO 2023 conference and a board member of the New York Geothermal Energy Organization. I'd like to welcome you to this recording of a live presentation from the conference, a two-day event which was held in Albany, New York on April 26th and 27th of 2023. This year's educational sessions and keynotes represent the latest in ground source heat pump system design, product innovations, and installation practices, along with important policy, regulatory, financing, and incentive updates. This presentation is one of over 40 sessions from the two-day event, all of which were recorded and available at NY-GEO's website, www.ny-geo.org, along with session descriptions and a link to download the slides from each of the sessions presented. NY-GEO is proud to make this content available to our members and other industry stakeholders, and if you are a member, thanks so much for your support and participation. If you find this content valuable and for some odd reason you are not yet a member, consider joining NY-GEO at the appropriate membership level with details available at our website. The live recording from the NY-GEO 2023 conference will start in just a moment. Thanks so much for listening.
So this is great. When John reached out to me and told me about this panel and this topic, I guess I wasn't too surprised. I work for a company, Brightcore Energy. We're a geo business, and give us a shameless plug because my boss is watching from somewhere. I'll be in trouble. But we're a New York-based company, and we're trying to help deploy more geothermal in New York and New England and northern mid-Atlantic. And I've been doing this for about 20 years. And I've been in a lot of meetings and I guess reviews over the year about what are the mechanical system options that a mechanical engineer reviewed for an option analysis, right? A lot of us know when you're working on a big commercial building project, there's a mechanical engineer that's involved. They're hired by other stakeholders, building developers, owners. Like, what are my options? And I want to do something that's super efficient. I've heard about geothermal. Will you do an option analysis? Like you throw that into the mix of boilers and other options, and they so quickly, I guess, find a reason that geothermal doesn't work on a particular building project. And one of the most common things that I've heard over the years is, well, we can't fit it. And for a real long time, I thought, yeah, that's the case. We can't fit it because you don't have a football field next to your building. Other than working on some projects over the years and having massive deviations of standing column wells off of property lines and having to grout up boreholes because we deviated by accident, it was just about 4 or 5 years ago that I realized that, hey, actually you can drill at angles on purpose. And it was probably through Stan Reitsma, who is one of the leaders in North America that has made this option available to people. And interesting then, over the years, I've ran into more people, made some more relationships, and I met Stefan Swartling, who is on our panel. And he, I guess, opened my eyes to what was being done overseas in Scandinavia. And apparently inclined boreholes have been installed for a very long time. A very, very long time. And actually yesterday, I was speaking to a colleague, Joran Helmstrom, who's here, who is trading stories, and his stories are always better than my stories because they go back way further. And we were talking about closed-loop geothermal, and he was telling me that he was involved with a first closed-loop geothermal system, multiple boreholes, to his knowledge, and I believe him. It goes back to 1977. And he was explaining that this system had multiple boreholes, and the monitoring of this system was used to derive some of the calculations that eventually made it into commercial modeling in modeling software. And by the way, this first system had boreholes that were installed at angles. So this type of installation isn't innovative. It's not new. It's actually the original way to install closed-loop geothermal to some degree. So super interesting. And also, I've just met Dmitry in the hallway, so we don't know each other yet, but it was really interesting to me once I saw Celsius enter the marketplace and find out that they were advanced at installing inclined boreholes in Europe as well. And so for me, this is really exciting stuff. I think that when we're talking to our mechanical engineering friends about, hey, this closed loop geothermal technology, we can't fit it here, we don't have a football field, that conversation's going to change due to the efforts and the work that are done by a lot of people on the panel and some other people that are part of this industry at this meeting. So, yeah, I guess we have some slides. I'm going to hand this off one by one as I introduce the panelists. First up is Stan Reitsma from GeoSource Energy out of the Ontario area, Hamilton, near Toronto. Stan and I have had the pleasure of working together recently. He's working with Brightcore. We're doing a great project together that some of you probably heard of. But Stan has been the CEO for GeoSource for about 20 years now. And he's an expert, and I'm going to hand this off to him to just tell us a little bit about projects and show us some slides. I think that you press the... Yes. Press the forward button.
Okay, I'll just go through. It's hopefully very quick here. So we got about 5 minutes, I've heard. So I just want to talk, we talk about off-center boreholes, which I had to ask the question, what do you mean? So we started getting into deviated holes and straight drillers. So anyways, that's a joke. But, okay, so why are we talking about angle boreholes? Right? And Dave obviously introduced it, is we can fit an awful lot more geo in a small surface space than has been at least thought of mainstream thinking on vertical boreholes. So there's two things. One is get more geothermal capacity into the ground in instances where you don't have access from surface with standard vertical spacing. So if we can't get 15-foot spacing to get the capacity we want, can we do it with angled holes? And often the answer is yes. Some of the reasons why it may not be always that apparent why we can't get it in, but there are a lot of things that cause issues with why we may want to go angled versus vertical, and some of them are here. So it's the obvious ones are surface obstructions, like a building's in the way, maybe there's green space for trees, lakes, can't get under the but there's also things like future use. So one of the things that we've been talking to people about is going, okay, so you got this great big football field, but do you think it's going to be a football field forever? Right? Talking about a science building maybe want to be built that later. Do you really want to go put a whole bunch of boreholes in, and then now that place is largely inaccessible to anything else other than a football field? Right? Nothing wrong with those, of course, but you may want to use it for something else. So future use, ongoing operations. So we're starting to see uses like EMS stations with ambulances going in and out, communications, all this kind of stuff happening while you're doing the drilling work. And try to do that and put a drill rig where an ambulance is supposed to go, and you're not going to get very far, right? So we've seen projects now where we're drilling in from the side while the ambulance facility is still working, and we're drilling in from the street or something close to the building, but outside of their roads. And then scheduling. So another part is if you're drilling in the middle of the site with vertical holes, you probably can't do much else there. And I think as people from Lend-Lease are here, you can attest to that we're in the way, right? So if not all cases, but in some cases, you can start doing those drilling operations from the side outside of your construction critical path. So those are some of the reasons why you may want to do it. down arrow, you said? Okay, so some of the typical candidates, there's actually almost any building is going to make sense for this. But one is on the drawing there, for example, it's kind of hard to tell but one's a building on the bottom, looks like asphalt, and then asphalt and this is probably either a Walmart or a Home Depot, right? So you box store type application where you have an ongoing operation with sales and people coming in, and so from safety and all that other stuff, you probably don't want to be doing any work up there. We are looking at a Home Depot in Ontario where they're looking at doing a retrofit where we come in and from the backside, drill everything out under the building into the, could be out under the parking lot, whatever, and they still can keep doing what they're doing every day and making money and doing what they do, servicing their customers while we do the drilling work, bring it in, and get the building retrofit. So there's just lots of reasons to do this. One thing I was going to say, and I think this is your pointing out earlier, was if you aren't sure, ask. Don't ever say no to Geo until you've asked, because there's a lot of things that we do that you don't necessarily are aware of, and it's changing very quickly. Yeah, so what are the kind of things that you have to get into for angled holes? And it's really very similar to vertical holes for drilling. So I know there's a drilling crowd here, and I wanted to put a drill rig in here because otherwise you think I'm actually an engineer and not a driller. I'm both, but we have drill rigs and we operate them. And so, but there's there's a few things that are probably critical to angle drilling outside of keeping your holes as straight as possible. Mast orientation, so you got to be able to position that mast. In this case, we now are operating rigs that can position side to side, front to back, so it gives you a lot more flexibility in the direction that you're drilling without having the machine necessarily in the position that you need to get that hole in the right direction. Positioning becomes a lot more critical because not only do you need to now go vertical with a pinpoint, you need to start at the right location and you got to end at the right location and you got to point it in that direction. And orientation, vertical is easy, angled, you need to have dip and direction. So those are a little more critical. And there's, you'll probably end up with $100,000 worth of gear on the rig just to get positioning correct, right? So there's a lot of stuff going on. In this case, you can see on the top of the machine there's actually a doubled GPS unit that is used on shipping, so it's from the marine environment. That gives you very accurate direction because there's 2 GPS units. And then casing and rod handling. When you start drilling angle holes, everything's out of alignment with the way that you handle your drill rods. So if you have a winch, everything gets loaded vertically, and you're trying to bring it into something that's on an angle. So how you do that becomes critical. And in our case, we use a lot of machine handling to do that. I just wanted one example here, and that'll be it. I'll get off. This is a job in Oakville, which is near Toronto. It's a federal research facility. What they do in there, I don't know. I'm not allowed to know, but we did the geo there. And when we went in, when it was designed, it was supposed to be vertical, but there was just so much stuff in there to try to work around that we finally said that we have to go angled. Can we do that? Can we propose something? And the engineer looked at it. We put something out to them, and they said, okay, we're okay with that. So that's the direction we went, and you'll see the next picture why. But this is a retrofit situation, which we would see is very common for this type of application, where you'll see in the next picture really what happens. So this is a picture from about 3 days ago. It's on the left side is that same drawing from the page before. The lines are all the angled holes, and then the blue dots or purple dots are the top of the boreholes. And they go fan out in both directions, and then the main header trench runs down the middle of those. And you can see all the different, So you're looking from the top of that trench there along there, and you can just see all the other utilities that we have to work around. And Jens, I'm sure you can speak to that, how that's not uncommon pretty much anywhere you work. What we're trying to do is get everything as compact as possible to get as little trenching as possible on the tie-in. So there's somebody asked me, is it more expensive to do angle holes? And the answer is yes. From the drilling perspective, it's probably, we think it's about 10% more. And most of that's related to positioning of the rigs and getting them onto those holes, because that takes time. But what costs extra on the drilling side costs less on the tie-in. So from a cost perspective, not always, but from a cost perspective, there's a lot less pipe going in the tie-in, and it's a lot less trenching and a lot less stuff to work around. In this case, we work around electrical conduits and storm sewers and sanitary and all sorts of other stuff only once, not every time you go across it because you went out over the whole parking lot. This building is also is operating, so there's people working in there, so this work can happen while that is happening. Anyways, so that's kind of an overview of angle drilling. Thank you.
Yeah. Great. Yeah, thanks a lot, Stan. I mean, this is really interesting stuff. Nothing like looking into a dirty trench and getting excited about that. I don't know about you, but this is like great. Yeah, so this isn't easy, right? It takes a lot of engineering and skilled technicians to do this type of work, period, even when you're drilling straight. I guess pulling back a little bit into engineering, because engineers are needed sometimes. I'd like to introduce Dmitry Kuravskiy. Yeah. Dmitry Kuravskiy, pardon my Russian. Dmitry is he's a drilling engineer. He's an expert in areas of drilling related to the petrochemical industry. He's working with Celsius, and he's bringing a lot of the innovation that he's developed in that area of expertise to our technology into the world of geothermal. So yeah, thanks. Without more ado.
Thank you, Dave.
I think I hit down for you. And there you go.
Okay, let me just check it out. Okay, thanks a lot for a chance to present. Dmitry Kuravskiy. As Dave mentioned, I'm basically coming from oil and gas background. I've been drilling the wells in oil and gas for the last 15 years in Middle East. I mean, the deepest, the longest, probably the longest one was 45,000 foot. So now we're basically trying to combine all this knowledge and bring it to the geothermal. And I see there is a lot of cool stuff I can bring here to make it more effective and to achieve way better results. And here in Celsius Energy, we kind of propose one of the solutions which implements some of the solutions from oil and gas. Is basically we are proposing the star topology approach when we're basically going with angled. Yeah. Yeah, no problem. So in Celsius, we're proposing star topology solution when basically we're using the angle drilling in a new featured way, when we're basically drilling all the wells from the central position, which basically one more step further in terms of applying the angle drilling approach. And this helps us to save even more space and basically to reduce our footprint on the customer sites. As a result, I mean, whatever was looking impossible before, we now can fit in the space of 10 by 20 feet container. We're placing roughly 20 to 21 wells. And for example, we can go to 40-foot well containers at 10 by 40. And this is like a quite significant reduction in terms of footprint compared to the traditional approach. As a result, you're getting much smaller footprint, you're getting fewer wells to be drilled, because even so this footprint on the surface is smaller, but on the bottom, because the wells are deviating, you actually affecting way more ground. So your volume of the ground which you're working with much higher compared to the traditional approach. As a result, you need fewer wells to be drilled to achieve similar result. And the best part of all of this, if you basically install the controls on these wells, you can basically, like a digital control, you can basically achieve almost infinite source of energy using the thermal battery approach. So, but the key of this solution is start topology approach. Let me see if I can. Basically, on the left side, you see the standard solution when we're basically occupying the field with multiple wells placed on the vertical grids. And on the right side, basically, when you basically place all the wells in the central location and just drill deviated. The deviation can be somewhere between 5 to 25 degrees. And the best part of this deviation is basically, if you look on the footprint and basically site destruction, you can see on the left side, when we go with traditional approach, you need to completely scrape and grade quite in significant areas. In terms of our solution, you basically can place it on the small parking lots, on basically on the side of buildings and etc. We still need to be mindful about the bottom hole area. So if you occupy the small space on surface, you still need to have quite significant space on the bottom to be able to place all the wells. And you need to place your wells inside this cube, inside your basically location property limits, correct? And this is basically where we're coming next. So when we talk about angle drilling, we're basically looking for some probably regulations or standards to be applied here, because to be honest, we do the angle drilling for some time, look like. On the left side, you see basically example of 2 vertical wells drilled recently in Massachusetts. I think Massachusetts or Connecticut. So, but as you can see, the dot on the bottom is basically the target, which is basically 25 foot radius target, which we're trying to hit. But you can see none of the wells is actually hit it. One well was roughly 40 foot away. Another well was around 180 foot away. And the only way to find out this is basically to run the surveys. So you basically run special tools and you survey the well and you figure out where this well is actually placed. And this current step is kind of missing from this equation, correct? So to be able to deliver the well vertically, or to deliver the well as actually at angle is becoming even more complex, because you're actually fighting with the gravity affecting the bottom hole assembly with drilling your hole. So you need to apply much more engineering in terms of design the assembly. You need to apply special stabilization techniques and special tools on the assembly, which help you to control the trajectory by basically optimizing the bottom hole assembly with special placement and tools. You're able to achieve your required tendencies. We call it bottom hole assembly tendency, correct? Your tendency can be dropping or building. It basically, if you assembly gaining the angle or dropping the angle. Same time, your tendency can have a walk tendency when the BHA's bottom hole assembly is moving left or right, correct? So all these 4 tendencies you need to address, and you make sure you are in control all of them to be able to achieve your target. So for this, it's not only about building assembly, correct? So building assembly is first step. The second step is about how you drill, correct? And this is where it's getting even more important, because the current rigs which we see, they don't really have much digital controls. They don't have much gauges, actually. So when the driller is drilling, it's basically all about his feeling. So you could not really capture the lessons, and you could not really convey the message. I need to apply this weight, and I need to apply this type of rotation, and I need to hold this torque on the assembly, correct? Because all these parameters together, they will define how you drill, and they will define the trajectory which you're building. After all this, basically when you deliver and you manage to succeed to deliver the well, the next step is basically you need to survey the well to be able to understand what you drill and what you deliver. And based on this, you adjust your assembly and you adjust your techniques. You're learning as you're going. Because right now we are not oil and gas. We could not apply this expensive real-time methods. In oil and gas, we can easily put the sensors in the assembly and we can basically collect the data as we go. In geothermal, it's kind of prohibitively expensive approach. So right now what we're doing, we're collecting the data, and then we basically have a self-learning model which basically adjusting and help us to adjust our assembly and parameters to be able to achieve the trajectory which we're looking for and to compensate for the tendency which we don't want, or basically to increase the tendency which we need. So moving forward, the reason why it was actually presented, I don't look and we don't look to kind of to apply a bunch of standards. But what is really important moving forward, if we go with angle drilling, is basically to make sure that we survey our wells, because we need to know where the wells is placed. We need to know that we actually respect the boundaries, correct? So could you imagine you're drilling in the Manhattan and you have a slot of 200 by 200 square foot area when you place 20 wells, and the well can deviate, as you saw, up to 180 foot, and it's vertical well, can you imagine how much can you deviate when you're drilling at 20-degree angle? So it's probably double of this. So, and that means you can drill easily to your neighbor. So as long if you don't deliver the surveys, it means you can easily violate the property boundary, and then you're basically getting in legal issues. Another issue with this is basically, besides the property boundaries, you can actually hit your own wells. Could you imagine you have a 40 wells which placed in this cube, correct? And they're basically like a spider going from each other. If some of the wells has a negative tendencies and some positive tendencies, you will basically cross and you collide the wells with each other. So the preventive measurement, you can adjust the future trajectory and you can basically plan forward. And as a result, you can reduce the collision issues. Collision issues, I think, accounted almost for 5% of wells. And it's 5% of the well collide. But the problem is when you collide, you actually damage another live well, correct? So actually, in result, you're damaging almost 10% of the wells. So which is basically increasing the cost of the project quite dramatically. So this technology is not really expensive, I mean, but it's help you to monitor the health and help you to monitor the legal issues which you can encounter in the future. And using this approach, you basically, it's need to be shareable data. It's not only for you. So if you survey the wells, you basically need to store it somewhere. I think it's more need to be on some kind of regulation side. Somebody need to collect this data. Similar to what we do with well reports, we'll collect this well survey reports in one data storage, then everybody can access. So you know when you go in the area, you know what wells are here, you know where to drill or where not to drill, and how to basically plan your cube accordingly, correct? Where you want to basically execute the job. Moving forward, understanding that there is some complexity, correct? And touching the complexity of angle drilling, I decided just to bring few points, not to be too scared, but this is something what really, I mean, come to my attention when I start to first work on this project. First point is when we're drilling under the angle, we start to encounter something called drag forces. So when you drill vertical, your rotational weight of the assembly, your weight when you're pulling assembly or when you're running assembly inside the hole is almost the same, so it doesn't really deviate, which is really cool and it's easy to work with. The problem when you deviate, you get the angle, you start to play with the drag forces, and drag forces always work against you, correct? So, for example, if you drilling ahead, you reach the total depth of 800 foot, and now you're trying to pull out assembly. The problem is instead of like weight, for example, of the string of 10,000 pounds, you will need to pull at least 14 to 18,000 pounds because you have a drag forces acting against you. And this is lead to the fact that you need to have way more powerful rigs compared to the traditional approach to be able to achieve similar depths in terms of design and execution. On other side, which is getting even more complex, I mean, if we talk about drilling, it's kind of okay, you have a power, you have a rig, but when we talk about completion, this is where geothermal world getting way more complex because you're using HDPE pipes, and these pipes have almost no buckling resistance. So, and right now the industry using approach when they're trying to push the pipes inside the hole. And when you push the pipe inside the hole, you have friction working against you, so you're actually buckling the pipe. The moment you buckle the HDPE pipe, it's extremely easy to basically collapse it when you start to put the grout because the pipe has a kick. Correct? So the pipe collapse rating is basically welded until point the pipe has a proper oval shape, circle shape. As soon as the shape of the HDPE pipe changed, basically when you're running it into a hole and you buckle it at least once. So when you put the grout or you put the cement for the grouting job, your pipes will collapse, and this will reduce, I mean, the best case scenario, it will reduce the capacity of the project. The worst case scenario, you will basically lose the completion, correct? So this is kind of one of the key challenges as I see it and at the current stage. Another point is a quite complex BHA approach that because you don't use any steering assemblies, like right now as Celsius as a part of the Big Blue, it's basically the oil service leader in oil and gas, Schlumberger. We're working in UK and Center to develop the rotary steerable systems. It's basically systems which are able to drill on demand. So you basically tell the system in which direction you want to go and how you want to go, and the system will execute the trajectory as per your needs. But this is kind of another level. We're working for the efficient and budget solution, probably a few years down the road. Right now at this stage, we're basically using the tendency studies and the AI learning to make sure we introduce the previous experience and previous trajectories inside the model and basically learning as we go. The challenge here is that these models are changing with the different locations, so each location has its own behavior, so you need to learn from the scratch on each location every time. And last but not least is the risk of pack-off and basically hole collapse is a bit higher on the angled wells because of the stress regimes are different, correct? So here you basically getting in the area when you need to be super cautious and you need to apply techniques like torque and drag. It's basically technique from oil and gas when we monitor the drag forces as we go, and based on this we're taking decision if we can proceed ahead or not, or we basically need to do the cleanup cycles and etc. So all this together, as Stan mentioned, makes the delivery of angled solutions a bit more expensive. But as you saw earlier, I mean, considering the reduction in the footprint and how much you can save on this, is basically all really beneficial. And the fact that it activates so many locations where you could not access before make it really a cool solution. So let us know if you're looking forward to implement one of them. That's it on my side.
Great.
Thank you.
Great. That's a lot of information to digest. But it's great to hear that people are, I guess, thinking about what could be the impediments to, I guess, furthering this technology, this way of sort of normalizing installation in these systems, right? Because drillers have to do this work. It has to be standardized. There has to be procedures that are put in place, process, I guess, right? I mean, there's process to everything that's done right now in a construction generally, right? So, yeah, these innovations are going to take some, it's going to be some lessons learned. Next, I'd like to introduce Mr. Stefan Swartling. Stefan and I have worked together for a few years now. Stefan, you didn't give me a bio, so I'm just going to wing it. Stefan and I, we met at a NY-GEO event, actually, about half a dozen years ago. He was working for a company that manufactured specialized drilling equipment. And from there, we just started to bring technology that he was instrumental to developing in Sweden to the United States. And I guess I'm going to hand this off to him and let him kind of just riff on his slides and kind of give you a little background of what he's done in the past with his colleagues and what we're doing together in the future.
And so a lot of technology, a lot of tooling has been developed for these kind of industries, which I think geothermal could benefit from.
Keep going.
Yeah, okay. Yeah. So I think the major twist in my presentation would be not accessing. Oh, we're fine. Okay.
Yeah,
okay. I never did it as a stand-up comedian, so I'm glad I have some support here. Yeah. No, but as you can see, most of the arguments for why we would drill at an angle or not straight is the same thing as Stan mentioned. I think it can increase the geothermal market quite extensively, not have the limitations of just drilling the vertical boreholes in any field. You can come closer to buildings, you can come inside buildings, and also depending on what method you're using, drilling technology or method, you can also avoid and take all the laws and regulations into consideration. So now what's the trick here? Was the arrow. Yeah. And Dave was also nice. Mentioned one of the first inclined borehole projects that we know of. It was in Stockholm, 1977, and Göran was a part of the design team there. And it was angled drilling, not that deep holes, but it was the reasons why they did that was difficult to access the area, and also it was storage, heat storage for solar. I mean, that's what we're talking about now. This was a few years back. Other aspects of it was also something which is interesting. It was a zone design. So if you look at the picture on the right-hand corner, the lower corner there, that's how the actually configuration of the holes was set into the ground in between these buildings. Here is, was that the right? No, yeah. Yeah, here's a couple of other examples. The first one is something that was built 1986. It was also, as you can see, another pattern, drilling pattern there, fairly close, but the angles up to 10-15 degrees, 6.5 foot spacing. It's called the Sun Court. and actually, I think they measured all the holes there and looked at the deviation. And the diagonal hole in between that is not a sort of a hole that is drifted off, it's actually a control hole. And I think it's still being measured, if I'm right informed. This was actually a little before when I was active, to be honest. The design to the right there is very interesting. That was actually not built, but it shows you the possibilities. You have a big community house there, and you have the dots in the periphery of the building there. It's actually the boreholes, and this was the modeling of it. So one additional point which I think should be made here is, of course, I think we can drill the holes, but you have to have somebody that designed the actual borehole system before you can go ahead and have the approvals and be confident that will this system actually works. I think we have the evidence that it works. We have done, I'm guessing, hundreds of them, at least 100 in Sweden. Here's another project. It's a data center. We talked about in one of these breaks here about data centers. They're massive producer of heat. They need cooling. So geothermal is a fantastic solution for that. When you had a data center, here is 2 ditches of holes, 2 meters apart approximately. And you see the first picture there is actually how it was designed, and the second one when they measured the holes afterwards when they've been drilling. I should say that this is air DTH, so it's fantastic result, but they were very keen on making them straight, so you had all kind of measures, stabilizers, and accurate tooling to run the rigs as well, and experienced people, I should say. Another area where inclined boreholes has some benefits is if you're drilling inside buildings, of course. You have existing buildings. We want to go geothermal, carbon-free, everything, you know. This is a project that we did. This is with the water hammer technology. 16 holes in the basement of a building, middle of Stockholm. Use a low headroom rig. And you see on the drawing to the right there, you see that we're aiming at the borders of the property to make it sort of fit within the rules and not having any effects with the city or municipality there. In this, we also tried a lot of new technology to the extent that we looked at what Dmitry mentioned, what control over the parameters of drilling, but also smaller hole size, as you can see. It was only 3.5-inch hole, and some special looping designs as well. And this was another project under a shopping mall in Gothenburg, Sweden. 80 holes. It was an old bowling alley. The holes are, I think there were some close to 200 meters. And today there is a grocery store built on top of this. And and that was also done with this water hammered DTH drilling technology. And as you can see on the drawing here, you see the the design of the beta system, and Göran actually did the design of this as well. Yeah. This is quite interesting, I would say. It shows you a number of inclined boreholes. This is city center Stockholm. So it's the apartment buildings, and they have the permission from the city to do the inclined boreholes. So that is absolutely nothing new. That's nothing they are even thinking about while you're drilling at an angle. And you have to do it because you can drill it from a court inside a condominium or a residential area, on the pavement, or in the basement, as you saw. I'm showing these pictures, as you understand, just to sort of think, okay, we can actually install geothermal in so many more places than we're currently doing. And actually, this is a project that is ongoing just now. This is in Copenhagen. You see at a 10-degree angle. The rig is maybe not the optimal one. It's a diesel-driven rig, so we have to channel the fumes out of the building. But it has this is also a water-powered DTH hammer, so it has water driving the hammer by a high-pressure pump. But you see, talking about cost, we understand that cost is slightly higher to set up a drilling site similar to this. I would say almost twice to standard drilling, or even an angle drilling situation. And as you know, as you know, I mean, these things also come with a lot of discussions with authorities, permits, and these things. So that's a big part of the projects themselves. Yeah. I think this has been touched on before, but if you look at, I mean, there's a number of things that you have to watch out for to make these as cost-effective as possible. You have to have the right equipment, the right bottom hole assemblies, you have to have the right operators, and you have to have follow the rules and regulations. But if you look at the picture there, or the illustration, that is actually the same reason, as I said, I came from mining. That company was doing underground mining. So in a drift, they were drilling upwards. It's called sublevel caving. But the same reason why they changed technology was to access more rock mass. So if you look at the longer, that is the configuration they're currently drilling with, they are 60, 70 meters long holes upwards, versus the other technology was traditional top hammer drilling. And for every blast, they actually get 5,000% more rock mass out of it. And what we need in geothermal is rock mass. Not to go away, this is actually already covered, but we see, I mean, if you're doing a design of some kind of system, you need to know where your holes goes. So you have to measure them one way or another, be pretty sure that they end up where they are. It's an additional cost, but it can be also very important. In this case, we have done a lot of measuring when it comes to deviation. The blue one is actually with water DTH. The yellow ones are with air DTH. And this is, I think, around 100 holes in 2 projects in Stockholm. But you see, they're pretty deep as well. I think we're talking about 250 meters, what is that, 1,000 feet or something? What else do we got? Nothing more, actually. Yeah, I hope that was a sort of a little bit of a mind opener. Thank you.
Thanks, Stefan. I think we have a couple minutes for questions. I have some like softball questions that I could ask these guys, or you guys could really hit them with some hard stuff. Any questions for the panel? I'll start left to right. I don't know if we have anyone to, I can do the.
I got it. Thank
okay,
you,
thanks,
Stefan.
Kevin.
I think this question is for you. I saw that photo where you said you could actually have the drilling rig inside of the courtyard. Just curious, how do you get a rig that size inside of one of those courtyards? Are you
Two options: either have a very small rig, or you can actually disassemble a rig. That have happened and will happen in New York as well. But in many cases, or in some cases, I should say at least, they are craning it in. So even if you are in between densely populated cities, so you bring in one of these construction cranes and what is it, 10,000 pounds or whatever it is, and then you actually lift it over the building.
Hey, question for the whole panel, I think. So with angle drilling comes a requirement of running surveys. What does that look like operationally? Are you drilling X amount of feet, then shooting off a survey, and continuing to drill, and shooting another survey? Does it involve tripping out of that hole to run the survey? What does that equipment look like?
I can start. In our case, I mean, it depends on area you are, correct? There is some areas like in New York, I think if you go deeper than 500 foot, the requirement to make a survey every 100. So there is a different techniques to do so. You can basically drill 100 and then just drop special device, measure, and then keep going. But in most of the areas, there is no such requirement. So what we normally do, we drill, and then we basically run the special device on the wire, and then basically we acquire the trajectory for the well.
I think what we used to a gyro actually, and measure it after the drilling is completed, unless there are special requirements.
I have a quick question here. Is there a limitation on how deep you can go with this inclined borehole? Is there a limitation on how deep you can go? I'm talking how deep, I mean the length of the borehole.
I'm going to say there isn't really a limitation other than obviously when it's angled, the further you go, the further it moves, even if it's a straight hole. So it has to stay on your property. So you're going to have some limitation either on the maximum angle that you could drill on, like from vertical, or how deep you go. So that might be the main limitation. But it would be normal depths as you would with verticals, as far as I understand, as far as we are experienced.
What about the difference in cost in drilling between regular vertical borehole and inclined borehole? Is there a big difference in cost?
I think the answer is if the rig is able to do verticals and angled holes, and it's all fairly automatic or set up to do that, the difference isn't huge. I do think when you're talking about what you're saying, getting inside buildings and so on, the cost can go way up. So, but our experience is it's a little bit of a premium, mainly because like drill speeds are largely the same, drilling toolings, stabilization's a little more, but generally speaking, it's the same. Everything's the same, other than positioning. So getting the rig set up is quite a bit of work to make sure that it's positioned accurately before you start.
Thank you. Do you need to speak with the neighboring property when you are planning to do inclined holes just to avoid future litigations? Thank you.
Well, I mean, you're applying for a drilling permit, and usually, this is my experience at least, then the neighbors are also informed that you're going to do drilling, and you're not allowed to drill on your neighbor's property. So that is, if you happen to do that, first of all, it would be difficult to check, but if somebody eventually want to do that, then there would be obviously a legal issue on that.
Yeah, I can say we're working in New York City doing a geo retrofit inside of a building in Midtown, It's generally part of the process when you get a DOB, a New York City DOB permit, that neighbors are notified of the work, that the work permits have been issued or are going to be issued, unless there's, I guess, somebody wants to take, I guess, a position against the work being done.
You guys talked a lot about borehole drag and just with angle drilling. How do you prevent during loop insertion the loop from being damaged and not wanting to drag on its way down the hole when you're? I know a couple of you guys touched base saying there's different tooling and methodology you might need to utilize than say just like traditional weighting. So how do you account for that?
Well, I was going to comment that buckling of loops is something that we've never seen, so I don't know. I was a little wondering maybe those are large holes that allowed buckling, but they're fairly close to vertical, right? So we're not talking about something that's at a 45 usually. It's like it's 10 to 15 degrees. I mean, they're almost vertical, so the amount of drag. Like our experience of pushing these, we push them in from the top typically. We're not seeing a lot of difference in the ability to get them in a vertical versus a hole that's on an angle. So, and we had no issues with pipe failure or that kind of thing. So, experience is telling me that there's not a lot of drag. The loops are fairly neutrally buoyant when they go in. They're actually floating probably, so there's maybe a little bit of top pressure on them. But regardless of, especially when you're pushing loops in, they're always going to be dragging to the side of the hole, whether there's an angle or they're always pushing out, trying to float in the hole if you're pushing on them. So we just don't see a lot of difference.
All right, we've got enough time for a couple more.
Dmitry, my question is, how are you achieving your angle drilling? Is it above ground or is it like in the gas industry where it's downhole deflection?
No, I mean, here you basically set from surface, correct? So you set the mast at the angle you want to go, you set the rig in direction you want to go, and you basically start going. So you basically align it and you go. And regarding the drag question, I mean, in terms of drag, exactly as Stan mentioned, because the loops has actually almost zero weight, and you have a force which is friction acting against them when you're pushing them. So there is, I mean, on the angles 20 plus, we saw some issues. So the way you basically addressing it, you're using the quite significant weighting techniques and basically filling up at the same time. So basically, in our case, we're running the field loops from the surface weighted up already, and this helps us basically to go much faster and prevent basically any kicking issues. And the reason why we think there is a kicking issue is because when we run the loops with the like classic techniques, when you're running the what you call it, I think loop feeder, correct? There is like a device which pushing the loops inside. So when you run later on, we have two survey methods. So one of the methods when you basically drop a survey tool inside the loops. So you can see that amount deflection you're getting inside the loops is just insane. So it's all the well is like crooked. So, and then when you're basically using the techniques with the loading and the proper basically weight distributions, and it's completely different.
Yeah, I think to kind of bring this back to Stan's joke about straight drillers, that it's impossible to stop drag. All right, one more question.
I had more of a kind of design question on what's basically how do you model like where you had like the formation where you have them angled in all different directions, like what kind of either assumptions or tools are you using to kind of come up with the performance of that?
I mean, there's special software, but it also comes with I think experience on systems that they have designed and measured. So we're pretty sure that the designs that they're currently doing measure up to the specifications. But there are, I would say, more advanced than the traditional design tools to do it. I think this is my the rule of thumb is if you have the square section of in the middle of the hole, let's say it's 500 feet at 250 feet, you have some kind of square shapes, and then you could sort of make just an estimate on what kind of system you have. If you compare that with the vertical.
Well, I think that's going to bring this to a close, and this is really great. Thanks everybody for spending your time, teaching everyone of your innovation, and thanks everybody for sitting here today and hopefully learning from this.